New study exposes one seriously strange fact about mice. When people see a mouse in their home, they tend to act in one of two ways: jump on the couch and cower, or run to the store and buy a bunch of medieval-looking mouse traps to lace their home with. Either way, most people don't look at mice as warm-hearted, helpful animals portrayed in stories like Cinderella. But scientists are the exception. Used to working in close quarters with mice as test subjects, the experts are familiar with all the quirks and qualities of the rodent. Still, even they were stunned by a new study that revealed a seriously strange fact about mice. German researchers at the Max Planck Institute of Neurobiology decided to use the gifts of modern tech to learn more about what goes on in the tiny brains of mice, specifically in relation to their facial expressions. What do they mean? You know how we humans use facial recognition technology to access our cell phones? Well, these scientists used custom facial recognition technology on mice. It turns out that their facial movements tell a story that we never once considered. According to Newsweek, the scientists fueled their algorithm with images of mice responding to varying stimuli, which included quinine to instigate disgust, sucrose for pleasure, lithium chloride for physical discomfort, escape to kindle active fear, and freezing for passive fear. Upon examining close-up footage of mice, subtle changes in their facial expressions became apparent. When mice experienced pain, their noses drooped and their ears pointed downwards. When mice experienced fear, their ears lifted upwards and their eyes grew wide. With each emotion these mice felt, there was one facial expression. Fear, however, spawned multiple facial expressions, including those that expressed pain and those instigated by bitter tastes. So mice produce facial expressions when feeling, just like us. A fine discovery, but these experts weren't satisfied. They dug deeper to see if they could detect the extent of said emotional states. For example, a thirsty mouse given a sucrose solution to drink appeared happier than a quenched mouse given a sucrose solution. Emotional intensity clearly runs on a spectrum. Scientists still had one question. Were these facial expressions instant reactions to certain stimuli, or did they correlate with the mice's internal emotional states? Though the mice looked elated while drinking sucrose solutions, perhaps they were daydreaming about the blissful tastes of cheese. The scientists were on the case. With our automated face recognition system, we can now measure the intensity and nature of an emotion on a timescale of milliseconds and compare it to the neuronal activity in relevant brain areas, said co-leader of the study, Nick Dolensek. They analyzed neural activity in the brain's insular cortex region, which is associated with emotions, via a fluorescent imaging technique called two-photon microscopy. The researchers then excited certain neurons associated with different emotions using light. Since the neurons and the facial expressions reacted at the same exact time with the same exact level of intensity, it was concluded that these are the responses to internal emotions. Maybe those happy mice really were daydreaming about sharp cheddar. So based on these results, it's possible there are individual neurons that could be accountable for animals' emotions, though the study's co-leader, Nadine Gogula, clarified that this point requires more research. The authors showed that changes in facial expression are not reflex-like reactions, but reflected some of the properties of emotions, such as balance, positive or negative, scalability, graded nature of emotional intensity, and flexibility, ability to flexibly regulate emotions, said neuroscientists Benoit Girard and Camilla Bellone. Though neither Benoit of Sorbonne University nor Camilla of the University of Geneva took part in the original research, they believed that the study has practical implications in our understanding of social behavior and interpersonal relationships. However, the two neuroscientists posed further questions. Considering us humans can fake a smile while internally feeling like the world is collapsing, fake it till you make it, can these tiny rodents perform such trickery as well? Though they'd have to continue studying the beady-eyed rodents to answer that, Nadine Gogula relayed, this is an important prerequisite for the investigation of emotions and possible disorders in their processing, such as in anxiety disorders or depression. Gogula, a neuroscientist, expects that by continuing the study of emotions in mice, scientists might gain a strong foundation for further understanding how emotions connected to anxiety and depression emerge in the brain. We hope that this will ultimately help us to understand how we can interfere with the activity in particular brain regions to ease people's suffering. Nadine continued. Though this mouse research is a revelation in the study of animal emotion, the German team knows it's only the beginning, as every animal is different. We don't exactly think and feel the same way a rodent that weighs 0.04 pounds does. And we bet you've never even considered mice as emotional animals to begin with. You likely only see them as vermin. Misconceptions about familiar animals aren't always based on the truth.